Have you ever wondered how vast the universe really is? Is it infinite or does it have an end? And if it does end, what lies beyond? The universe, the very fabric of our existence, is a mystery that continues to baffle us. In its sheer vastness, it holds countless galaxies, each teeming with billions of stars and planets, all separated by the seemingly endless expanse of space. This grand cosmic stage wasn't always as we see it now. There was a time when there was nothing. No stars, no galaxies, no planets. Just a singularity, a point of infinite density and heat, waiting to explode and give birth to everything we know. This explosion, known to us as the Big Bang, marked the birth of our universe and set in motion the ongoing expansion we still witness today. The universe has been growing ever since, in both space and complexity. Well, to understand that, let's journey back in time to the very beginning. The Big Bang. Imagine everything that exists, compressed into an infinitely small, dense and hot point. Then, in an instant, an explosion. The Big Bang. This fiery birth of reality as we know it happened approximately 13.8 billion years ago. Picture it as the ultimate magic show, where, from virtually nothing, everything we can perceive today was brought into existence. The Big Bang Theory, as it's called, isn't about an explosion in the conventional sense, but rather an expansion so vast that it's still ongoing and our universe continues to grow even as we speak. From the infinitesimal to the infinite, the Big Bang set the universe into motion. In its wake, it left a universe that was unimaginably hot and dense. But just as a dancer spins more slowly as she extends her arms, the universe too began to cool as it expanded. This cooling was vital. As the universe expanded, the intense heat also began to dissipate. And as it cooled, matter began to form. In the beginning, this matter was just a hot, dense soup of particles constantly smashing into each other. But as the universe continued to cool and expand, these particles began to coalesce, forming atoms, the building blocks of everything we see today. Yet, this wasn't a smooth or even process. Some areas of the universe had slightly more matter, and these areas began to collapse under their own gravity. These regions would eventually form the galaxies and the stars, the cosmic structures we see in the night sky. So, what started as an unfathomably hot, dense point, has expanded and cooled over billions of years, giving rise to the galaxies, stars, planets, and even life itself. The universe is a vast, dynamic stage, and the Big Bang was the first act in its cosmic play. From this fiery, chaotic beginning, the universe as we know it began to take shape. It's an ongoing journey, one that we're only just beginning to understand. But one thing's for sure, the story of our universe is the greatest story ever told. In the aftermath of the Big Bang, the universe was a hot, dense sea of particles. But as it expanded, it began to cool. This cooling process wasn't an overnight occurrence, but a gradual decline in temperature over a vast expanse of time, leading to the formation of matter as we know it. Only a second after the Big Bang, the universe was already teeming with particles. Imagine, in this primordial soup, a vast array of neutrons, protons, electrons, anti-electrons, also known as positrons, photons, and neutrinos. This was a universe in its infancy, a wild, chaotic dance of particles colliding, combining, and annihilating each other. As the universe continued to expand, it cooled further. This cooling was pivotal as it allowed for the formation of the first atoms. Protons and neutrons began to come together to form the nuclei of simple elements, the building blocks of everything we see today. The electrons, which had been zipping around freely, were now slow enough to be captured by these atomic nuclei, creating the first atoms. This process, known as recombination, allowed light to travel freely for the first time as the universe became transparent instead of an opaque fog. But what about the anti-electrons or positrons? These met their end rather dramatically. When a positron came into contact with an electron, they would annihilate each other, releasing energy in the form of photons. This process significantly reduced the number of positrons in the universe, leaving a surplus of electrons and paving the way for a universe made of matter, not antimatter. And the neutrinos? They decoupled from the rest of the matter and continued to pervade the universe, rarely interacting with other particles. Billions of these ghostly particles pass through us every second, a cosmic reminder of our universe's fiery birth. This was the beginning of the formation of the universe we are familiar with today. A universe born from a hot, dense point, expanding and cooling, giving rise to the matter that makes up galaxies, stars, planets, and even us. In the first 3 minutes of the universe, an important process occurred. Big Bang nucleosynthesis. This phenomenal event saw the creation of light elements, a crucial step in the journey of our universe. The universe at this stage was a hot, dense sea of neutrons, protons, electrons, anti-electrons, photons, and neutrinos. As it expanded and cooled, protons and neutrons began to combine to form the nuclei of simple elements, hydrogen, helium, and lithium. This process, known as Big Bang nucleosynthesis, was responsible for generating the light elements that make up about 98% of the universe's matter. It's a cosmic forge that worked at unimaginable temperatures and pressures, shaping the raw materials of the universe into the building blocks of everything we see around us today. From the water we drink, to the air we breathe, and the stars we gaze upon, they all owe their existence to these light elements. With the birth of these light elements, the stage was set for the formation of stars and galaxies. As the universe continued to cool and expand, structures began to take shape: galaxies, stars, and eventually, planets. As the universe cooled, tiny fluctuations in the density of the primordial soup of particles began to grow under the force of gravity. These fluctuations, ever so slight, created regions of higher and lower density in the universe. The denser regions attracted more matter, and as they did, they grew even denser. This cycle continued, and over billions of years, these high-density regions became the galaxies we see today. Within these galaxies, pockets of gas and dust began to collapse under their own gravity, forming stars. The process of star formation is one of the most beautiful and complex phenomena in the universe. It involves a delicate balance between the outward pressure of nuclear fusion and the inward pull of gravity. When a star's life ends in a spectacular explosion known as a supernova, it spews out heavy elements into space. These elements, like iron, silicon, and carbon, are the building blocks of planets. Planets, like our own Earth, came into existence as a byproduct of star formation. Around a young star, a disk of gas and dust forms. Within this disk, solid particles collide and stick together, gradually building up to form planetesimals, the seeds of planets. Over time, these planetesimals accumulate more and more material, growing into fully fledged planets. This process of cosmic evolution is still happening today. Even as we speak, space is expanding, galaxies are forming, stars are being born and dying, and new planets are coming into existence. The universe is not a static place, but a dynamic and ever-changing entity. So, the universe we inhabit today, with its countless stars, galaxies, and planets, is the result of billions of years of expansion and evolution. So, back to our initial question, how vast is the universe? Is it infinite? As we've journeyed through the birth and expansion of the universe, we've encountered atoms forming, light elements being born, and space stretching beyond our comprehension. But how vast is this cosmos that we're a part of? Is there an edge, a boundary where everything ends, or does it continue endlessly into infinity? Theories abound, each more intriguing than the last. One school of thought proposes that the universe is flat and goes on forever. If you were to travel in a straight line, you'd keep going, never returning to your starting point. Another theory suggests that the universe might be curved, like the surface of a sphere. In this case, if you set off in one direction and kept going, you'd eventually end up right back where you started, having traversed the entire universe. Yet another theory posits that the universe could be like a saddle, curved in one direction and arching in another. This model suggests a universe that's infinite in extent but still has a finite volume. The truth is, we don't know for certain. Our understanding of the universe is limited by our observation, which is constrained by the speed of light. There's a cosmic horizon beyond which we simply cannot see. But don't let this uncertainty dismay you. Instead, let it inspire awe and wonder. For every question we answer, a dozen more arise, pushing us to learn, to explore, to understand. We may be small, but our thirst for knowledge is as vast as the universe we strive to understand. While we may not have definitive answers, the exploration and understanding of our universe is a testament to human curiosity and our relentless quest for knowledge.